Hello everyone, my name is Torben Vogt. I'm a specialist electromagnetics in Altair, and today I'm going to talk about the numerical Green's function in Feko. So numerical Green's functions, or short NGF in Feko, what is this? Here's some background. Well, a MOM or method of moment simulations have this, or typically have this large system matrix, which is causing probably long runtimes and huge memory consumption. With the numerical Green's functions, you have the option to divide your model into a static part and a dynamic part. And yeah, the dynamic part is typically a part that can be moved around in the model, while the static part is, like the name says, it's static, it's fixed. So when using the NGF, the system matrix of the MOM simulation is divided into a static part, as you see here. This is typically the larger part, and the dynamic part, which is typically a smaller part. And by dividing it, you can save a lot of runtime. That's the basic reason to use the NGF. So for example, for this helicopter model, the helicopter itself is the static part in this case, and we have a monopole, and we let it move around. We put it on different locations, and the monopole is the dynamic part. The numerical Green's function, it stores an NGF file on the hard disk in the folder of the model. Could be several NGF files, by the way, if you use multi-core. And yeah, that's basically it. I have prepared a simple example here. We have this dipole, just a simple wire dipole placed upon a piece of dielectric substrate. And this then is located on top of a large ground plane. And I want to move the dipole to 4 different locations, as you see here on the right side. And I will use the NGF to increase the simulation speed. So in CAD Feko, this is how it would look when you enable the NGF. You just open the dialog and then you enable the numerical Green's functions. Also, what you typically do is that you lock the static parts. That means that the mesh of the static parts, it will not be changed afterwards. It will be fixed. Yeah, maybe here to move around parts in Feko, you have more than one option. So typically you will just manually move it using the translate option maybe, or the rotate option or whatever. You have also the option to use the parameter sweep for that. This will then, like you see here, this will then automatically create the 4, in this case, models for you. Okay, let me open CAD Feko, where I have the model already loaded. Here it is. So yeah, you see we have a ground plane and a dipole and substrate part, so 2 different parts. Now I want to use the NGF, so I switch to solve runtime up here, and there is the NGF. When I click on it, I can enable the numerical Green's function. The lock static parts is already by default enabled, and it has already picked the ground. That is from previous tests that I did. So let me once again delete that and click here, then click here, say OK. And now we have this lock symbol here, which means that the mesh will remain untouched. And also we have the NGF symbol here, which means this is now the static part. Okay, next step, I will move the dipole around to 4 different locations. So let me quickly do that manually here. So I right click here, say transform, translate it to the first position. For example, here, I will save the model example underscore 1. Then let me move the dipole to the second location, maybe here. Save it under example underscore 2. And let me move the dipole to the third location, maybe here. Save as example underscore 3. And now finally move it to the final location and save as example underscore 4. So basically I can now run all 4 models, and we will see that only the first simulation will take long, or as long as it would do without NGF, maybe slightly longer due to saving the NGF files. But then example 2, 3, and 4 will be reasonably quicker. Okay, I did run the simulations earlier, obviously on a slightly bigger machine. So let's go back to the slides here. And yeah, I summarized the runtimes for you. So on the left side, you would see, or you see the runtime as it would be without the numerical greens function. So they are, as expected, more or less the same for all situations. So the number of unknowns or the number of mesh elements is roughly the same for all the 4 models, so the runtime as well. And in total, we have runtime of 378 seconds almost. Now, with using NGF, like I said, only the first simulation really took long. This then stored, in this case, 8 NGF files because we used 8 cores in parallel. And you see that position 2, 3, and 4 were reasonably fast. In total, we had only slightly above 200 seconds in this case. And that's it. Thank you.